All right, welcome back, everyone. Ready for another deep dive.
Definitely. Always up for exploring something new.
Well, this time we're wading into the world of blockchain, specifically Solana. You sent over some fascinating bits from their white paper, version 0.8.13, and whoa, it gets pretty deep. White papers, am I right? Sometimes they feel like they're written in a whole other language.
Tell me about it. Definitely not light reading material.
That's why we're here, to decode the jargon and figure out what's really exciting about this Solana thing.
Exactly. Got to separate the hype from the real deal, right?
Absolutely. So before we get lost in the technical weeds, any burning questions you had about Solana coming in? What piqued your interest?
Well, one thing that jumped out at me was this whole idea of consensus, how Solana tackles that fundamental blockchain puzzle.
Consensus. Okay. Sounds simple enough, but we're in decentralized territory here. No referees, no central bank calling the shots. So when we say consensus in this context, what does that actually mean on the Solana network?
Yeah, it's the core of the issue, isn't it? In a
Mhm.
traditional system, you've got your bank, your authority figure, verifying everything, keeping things in line. But with blockchain, the whole point is to ditch that central control point. So then how do you make sure everyone's on the same page about the order of transactions, the timing, when anyone can theoretically join the party?
Right, like herding digital cats or something. That's where I started getting
And
lost.
that's where Solana throws out this curveball, they call it proof of history,
Ah.
POH for short, like a trustless passage of time, the white
This
paper says.
trustless passage of time. Okay, now we're getting into some serious sci-fi territory. What does that even mean?
It's wild, right? Imagine a system where you don't need to take anyone's word for it, not even some universal clock to agree on when something went down. That's what they're going for.
So Solana's found a way to actually prove the passage of time within the blockchain itself. My head's spinning a bit.
It's a mind bender for sure. But think of it like this. Imagine a logbook, but it's tamper-proof. Every single entry is linked to the one before it. Unbreakable chain.
Okay, I'm picturing it like those old school accounting ledgers.
Exactly. And Solana's using these things called hash functions to represent time passing. Each tick of the clock is a new hash.
Hold on, back up a sec. Hash function, for those of us who aren't cryptography wizards, what are we talking about here?
It's like a special recipe. You put any data in, could be a tiny bit or a whole novel, and the recipe spits out this unique fingerprint of that data. Always the same length, virtually impossible to fake.
So if even one letter in that novel is different, the fingerprint changes completely.
Exactly. Tamper-proof seal. Now here's the Solana twist. They chain these hash functions together.
Hmm.
The output of one becomes the ingredient for the next, and so on. This creates a continuous verifiable sequence.
So each hash is like a tiny unit of time, all linked together.
You got it. But then the question becomes, how do we know this logbook is legit? Could someone cook up their own POH and claim it's the real deal?
Yeah, good point. That's what always makes me nervous about these decentralized things. Seems like you're taking a lot on trust.
And that's what's so groundbreaking. Anyone can check Solana's work because it's all based on those cryptographic hashes. It's like math, pure and simple. Do the same problem, you get the same answer every time. If someone tries to mess with the sequence, it'd be obvious. Like trying to reorder events in a history book, the inconsistencies would be glaring.
So it's verifiable because the math has to add up.
Exactly. And to make it even more ironclad, Solana pulls in timestamps from real-world events into this whole POH sequence.
Wait, seriously, like they'll grab a headline from, say, the New York Times at a specific moment.
Got it. Makes it impossible to fudge the timeline. You'd have to rewrite history itself.
That is wild. Seems like they've cracked the code on creating a system that's truly tamper-proof. But how does this actually translate to a faster, more efficient blockchain? Because that's the promise, right?
That's where it gets really interesting. With proof of history, Solana cuts out a ton of the back and forth that bogs down other blockchains. But it's not just about speed. It's about how much it can handle and how secure it all is.
You mentioned scalability. With proof of history, does that mean Solana can handle a massive amount of transactions without breaking a sweat? Because that's been a hurdle for other blockchains, hasn't it?
Absolutely. That's another area where Solana shines. The white paper projects that Solana could handle over 700,000 transactions per second.
700,000. To put that in perspective for our listeners, how much faster is that compared to, say, something like Bitcoin?
Orders of magnitude faster. It's like comparing a horse-drawn carriage to a supersonic jet. This kind of speed and scalability opens up a whole new world of possibilities for what we can do with blockchain technology.
That's incredible. But how does Solana achieve these speeds? Is it just the proof of history mechanism, or is there more to it?
Proof of history is a huge part of it, but Solana also optimizes every layer of its architecture for speed. For example, they use something called a pipeline design for transaction processing.
A pipeline design. That sounds more like something you'd find in a factory.
That's a great analogy. Imagine a manufacturing assembly line where each step of the process happens simultaneously. Instead of waiting for one step to finish before starting the next, Solana pipelines transactions so that they're being processed concurrently at different stages. This parallel processing is like having a team of experts working on different parts of a problem at the same time, which significantly speeds things up.
That makes sense. But with all this talk about speed and efficiency, we can't forget about security. The white paper does mention something called proof of stake. How does that fit into the picture?
You're right, security is paramount, and Solana addresses it in a clever way with proof of stake. In essence, it's a system that incentivizes good behavior among those who help maintain the blockchain. These are known as validators.
So validators are like the guardians of the network, ensuring everything runs smoothly. But what's their incentive to play by the rules?
Well, with proof of stake, validators have to put up a significant amount of their own cryptocurrency as collateral. Think of it like a security deposit. If they try to cheat or compromise the network, they risk losing their stake.
So it's like having skin in the game. They're more likely to act in the best interest of the network because they have something to lose.
Exactly. It's a powerful mechanism for aligning incentives and ensuring the integrity of the blockchain.
It sounds like proof of stake adds an extra layer of security on top of the already ingenious proof of history mechanism. But what about the data itself? How does Solana ensure that all this information is stored securely and reliably?
That's where proof of replication comes in. Remember how we talked about validators being responsible for maintaining the blockchain? Well, with proof of replication, Solana ensures that these validators are actually storing copies of the blockchain's data.
So instead of relying on a single source of truth, the information is distributed across multiple validators.
Precisely. It's like having backups upon backups. And Solana uses clever cryptographic techniques to make sure that these backups are accurate and tamper-proof. This distributed storage approach makes the network incredibly resilient because even if one or several validators fail, the data is still safe and sound.
It sounds like Solana has thought of everything when it comes to speed, scalability, and security.
They really have. But they don't stop there.
There's more. Tell me everything.
The Solana whitepaper goes beyond the fundamentals and delves into some really fascinating areas, like their approach to smart contracts.
Smart contracts, now we're talking. Smart contracts, those are like the building blocks of really cool stuff on the blockchain, right? But just in case, remind us, what exactly are they?
Think of them like a digital agreement that enforces itself. Let's say you and I make a bet about, I don't know, which one of us can hold our breath the longest.
Always a safe set for me.
Right. So we write a smart contract that says the winner gets bragging rights forever. Once we finish the challenge and it's recorded on the blockchain, boom, contract automatically knows who won.
So it's like having a robot referee who never misses a call.
Exactly. And because these contracts live on the blockchain, they're super secure, transparent, no funny business.
That's what I like to hear. But what makes Solana's approach different? Everyone's doing smart contracts these days.
One thing that caught my eye was their use of this eBPF bytecode.
eBPF bytecode. Sounds like we're building a spaceship, not a blockchain.
It's a mouthful, I know, but stay with me. Imagine you're building something, right? You could start from scratch every single time, or you could have these pre-made, super reliable parts that just click together. That's eBPF for Solana's smart contracts.
So it's like a shortcut for developers. They don't have to reinvent the wheel every time?
Exactly. Faster, more efficient, and more secure. Because those pre-built parts have already been tested and poked and prodded for weaknesses.
Makes sense. But then the white paper throws out this other term, zero-cost foreign function interface. Okay, now you've lost me completely.
I like to imagine it like this. You're cooking from a recipe, and it calls for this really specific tool, like, I don't know, a spiralizer, to make zucchini noodles.
You and your zucchini noodles.
Hey, don't judge. The point is, instead of having to build a spiralizer just for this recipe, you can just barrel one, right? That's what Solana's doing, providing these pre-built tools for smart contracts.
So they can tap into some serious functionality without slowing the whole system down.
Exactly. It opens up a world of possibilities. Complex calculations, external data, all without bogging down the blockchain. A dream for developers.
Wow. After this deep dive, I'm starting to see why people are so excited about Solana. They've really thought this through.
They haven't cut corners. But like with any new tech, there's always some level of risk.
Right. Even with all this amazing tech, nothing is 100% foolproof.
Absolutely. The Solana team acknowledges this. They even have a whole section in the white paper on potential attack vectors.
Oh, so they're not shying away from the tough questions.
Not at all. They get into the weeds, talk about what could happen if, say, a bunch of validators decided to go rogue, or if there's some flaw in the proof of history we haven't thought of yet.
It's a good reminder that even in this decentralized world, security is an ongoing battle.
It's an arms race. It never stops, which is why it's so important to keep learning, keep pushing the boundaries.
Couldn't agree more. This has been an amazing journey into the heart of Solana. We've covered so much ground, from their mind-bending proof of history to their incredibly ambitious approach to building a truly robust blockchain.
And this is just scratching the surface. The Solana ecosystem is constantly evolving. New applications are popping up all the time. It's a really exciting space to be watching.
Absolutely. It's a testament to how quickly things move in this space, and that's why we do these deep dives to make sure we're staying ahead of the curve and helping you do the same. So to everyone listening, stay curious, keep exploring, and we'll catch you on the next deep dive.